Okay, now we have sound. First of all, what exactly is sound? Sound is technically an energy, right? It's an intangible but audible energy produced by vibrations. Now, when we come to sound, we have to first figure out that sound travels as waves. What is a wave? A wave is nothing but a disturbance. And sound travels as longitudinal waves most of the time, but it can even act as transverse waves in some cases in some special media. Now, sound is a mechanical wave, and that is very important because sound always requires a medium to travel. It cannot travel through vacuum. Now, a very important thing is that why does it have to travel through a medium? This is because sound propagates through particles in a series of compressions and rarefactions. Now, we have to keep in mind that a compression is when they come closer to each other, the density is high, the pressure is high, everything is high. And in rarefactions, let's just say the molecules are chilled out and they are spread over the area. No pressure is being applied on them. Their density is also low. Everything is low over there. So when we plot this, we actually get the wave. Now this lambda, which I've drawn over here, this shows the wavelength. The upper parts, which are above the equilibrium or the zero state, this is called the crest, and the down parts are called a trough. And the distance from here to here, it's called amplitude. And of course, we know that sound is vibrations, right? So the number of oscillations per unit time is called the frequency, right? So it's 1 by t. A very important formula which we have to remember in sound is that V is equal to frequency into wavelength. This is a very important formula. Also, another thing which I've not written here but is very important is echo. So echo is when you produce a sound and it bounces off a shiny object and comes back. We have to keep in mind that sound obeys all the laws of reflection. I is equal to R, all the three lines are on the same plane. All of that applies to sound as well. Now, speed of sound, take anything from 330 to 340. It normally does not matter, but if something has been specified in the question, please take that. Now, we have to remember that in echo, it travels two distances. It does not travel only once. It travels twice. It hits, then it comes back. Very important another concept is the perception of hearing. Now, of course, we all know how we hear. Our eardrum vibrates, then it's transferred to the brain through the auditory nerve. But another important concept is there is something called the persistence of hearing. So if we hear something in less than 1 by 10th of a second, we are going to think that it's the same sound. And that's exactly why even if there is a lot of echo right now, I can't hear it because the room isn't that big. And that big as in 17.2 meters. That's the least distance it has to go and bounce back for us to be able to hear the echo. Now, what is a pulse? So a pulse is a single disturbance. So it's just one push. A very important thing is the Slinky experiment, something which I won't be covering today. Now, another three things. What does sound depend on? We have loudness, which depends on amplitude, pitch, which depends on frequency, and we have quality or timbre, which depends on waveform. This is all very important. Now, a little bit of physics and biology over here. The human ear can hear between 20 to 20,000 hertz. Anything below 20 is called infrasonic, and anything above 20,000 is called ultrasonic. Dogs and bats can hear, and that's why they are trained in special ways. Bats use ultrasonic to actually get their way because they are literally blind. Now, that's that. Now, there is another two things which we have to know. It is a note and a tone. Now, what is a note? A note is a set of different tones produced together, and that's like a set of, it's like music. So it's like, so that's a note. But if there is one particular frequency being produced all the time, that's literally giving pain to your ears, it's normally produced by tuning fork, that is called a tone. So that's that about sound. And yeah, just practice all this, practice all the numericals. And another very important thing is know the difference between noise and notes. That always comes. Thank you. Bye-bye.